Good morning, class. My name is Mark Evan Emonia, and my group members is Jimol de la Cruz and Mark Daniel de la Cuesta. So, we are Group 2, and we are excited to present our reporting to you today. Our topic is glass and ceramics, two materials that that have been used for thousands of years and continue to be essential components in a wide range of industry. We have researched the unique properties and characteristics of this material, their manufacturing processes, and common application. Additionally, we have explored the environmental impact of glass and ceramics and emerging technologies in the field. We hope that you will find our finding informative and insightful, and we look forward to sharing our work with you today. So, see, glass and ceramics are two distinct materials with unique properties and characteristics. Glass. Glass is an inorganic solid material that is usually transparent or translucent as well as hard, brittle, and impervious to the natural element. So, ang glass ay isang crystalline solid dahil nga wala siyang maayos na pagkakabuo ng mga kristal. Ang glass ay karaniwang ginagawa sa pamamagitan ng pagme-melting ng mga material such as sand, soda ash, and limestone. Maaari ring gawing glass ang iba pang mga material tulad ng boron, aluminum, and potassium. So, ceramics. A ceramic is an inorganic non-metallic solid made up of either metal or non-metal compounds that have been shaped and then hardened by heating to a high temperature. In general, they are hard, corrosion, resistant, and brittle. So, ceramics naman are crystalline or partially crystalline solid made by heating and cooling inorganic non-metallic materials. Ang non-metallic material niya ay si clay, feldspar, and alumina. Ceramic are characterized by their hardness, brittleness, high melting points, and excellent electrical and thermal insulation properties. They are commonly used in wide range of application, including pottery, tiles, refractory material, electronics, and dental implants. Glass versus ceramics. The term glass was first developed during the late Roman Empire. Ceramics comes from Greek word keramikos, which means pottery and keramos, which means potter's clay. Ang term glass ang nanggaling sa Old English word glaze, which is derived from the late Latin word glasses, which mean a vessel made of glass. The use of glass dates back to ancient time, with evidence of glass production dating as far back as 3,500 BCE in Mesopotamia. Ang word naman na ceramics ay nagmula sa salitang Greek na keramikos, na ibig sabihin ay of pottery o for pottery. Matagal nang ginawa ng tao ang ceramics sa loob ng libu-libong taon. At mayroong ebidensya na ang pottery ay nagmula pa noong 24,000 BCE. Nabago ang paggamit ng ceramics sa paglipas ng mga panahon, kung saan umunlad ang mga materials, mga teknik ng mga tao sa product na humantong sa pagdevelop ng iba't ibang product ng ceramics para sa iba't ibang mga application. Glass is known to be a non-crystalline material. It is an amorphous solid, which means that it has no long-range order of positioning of its molecules. Kahit pareho silang organic material, madalas na hindi tinuturing ang glass bilang isang uri ng ceramics dahil wala itong crystalline structure na kadalasang mayroon palagi ang ceramics. Ang glass ay isang amorphous solid kung saan ang meaning mayroon itong hindi maayos na atomic structure without long-range order na sinasabi na hindi ito katulad ng ceramics na mayroong kadalasang crystalline structure. Ceramic can be termed as an inorganic material. Unlike glass, ceramics may have crystalline or partly crystalline structure. Ceramic may also be amorphous. Ceramics have a crystalline or partially crystalline structure, which gives them their characteristic property, such as high melting points, hardness, and brittleness. The crystalline structure of ceramic arises from the regular arrangement of their constituent atoms or molecules in a repeating pattern, which gives them long-range order. Ang glass at ceramics ay hindi organic materials. Ang mga ito ay nakilala sa pamamagitan ng kanilang atomic structure at yung mga properties na ang glass ay isang amorphous solid at ang ceramics naman ay crystalline or partially crystalline. Silicon dioxide is the main component of glass. Glass is a mixture of two or more kinds of metallic silicates. Clay is the main component in ceramics. Silicon dioxide, also known as silica. Ito yung pangunahing material ng glass. Madalas kasama ang silicon dioxide sa iba pang mga materials tulad ng soda at limestone upang makagawa ng glass. Samantala naman ang clay ay ang pangunahing material ng ceramics. Isang uri ito ng sedimentary rock na binubuo ng mga mineral grains tulad ng kaolinite, feldspar, at quartz. Glass is also transparent, which means light passes through it. Ceramic may be opaque, which means it does not allow light to pass through it. Yes, that is correct. Glass is transparent, which means that is allowed light to pass through it na nagbibigay daan ng liwanag upang makakita sa magkabilang banda ng glass. Then, about naman sa ceramics ay maaari hindi mo makikita ang liwanag na tumatagos sa magkabilang side. Well, glass and ceramics are widely used for making household utensils. Apart from making household materials, glass and ceramic have found their place in many areas. Yes, madaming natulong ang glass and ceramics sa ating bahay. So, kagaya na nga lang din ng example ay architecture and construction. Glass is widely used in architecture construction sa mga doors, facades, and other applications. Sa ceramics naman ay roofing, flooring, and wall cladding. Sa electronics, sample nito ay LCD display, touchscreen, and semiconductor packaging. Medical and scientific equipment, mga laboratory glassware, optical lenses, and implants. Sa art and decoration, stained glass, ceramic tiles, pottery. Sa airspace and defense, sa mga heat shield, missile nose cones, and transparent armor. Sa energy, yung mga solar panel, fuel cells, and insulator. There are just a few example of the many application of glass and ceramic. Their unique properties such as transparency, strength, and heat resistance make them versatile materials for a wide range of uses. How glass is made. So number one, raw materials. The first step in making glass is gather the raw materials needed to make it. Main raw materials used in making glass are silica sand, soda ash, and limestone. These materials are usually gathered from natural sources such as beaches, quarries, or mines. Once the raw material have been gathered, they are typically transported to glass-making facilities where they are mixed together in a specific proportion to create the glass batch. The batch is then melted in a furnace and shaped into the desired form using various techniques such as blowing, molding, or pressing, mixing and melting. The raw material are mixed together and heated in a furnace at very high temperatures, typically around 1700 degrees Celsius. In the mixing and melting stage of glass making, the raw materials are combined and heated in a furnace at extremely high temperature, resulting in a molten glass mixture. This result is created by combining silica sand, soda ash, and limestone. This high heat causes the raw material to liquefy and fuse together, forming the basis of the glass that will be created. Refining. The molten glass mixture is then refined to remove any bubbles and impurities that may have formed during the melting process. After the raw material have been mixed and melted in the furnace, ang molten ay nag-aalis ng anumang mga bula o dumi na maaring nabuo noong nagme-melting. Ito ay isang mahalagang hakbang sa paglikha ng mga glass na may mataas sa kalidad. The refining process involves stirring the molten glass mixture to break up any bubbles that may have formed, and then skimming off any impurities that rise to the surface. So, nakakatulong to ensure that the final product is clear, uniform, and free of defects. Once the refining process is complete, the molten glass is ready to be formed into the desired shape and product. How glass is made? Forming the molten glass is then formed into the desired shape using one of several methods. So, blowing. In blowing, the glass is heated again and air is blown into it through a blowpipe or other tool to create a bubble. The bubble is then shaped and manipulated until it's formed the desired shape. So in pressing, the molten glass is poured into a mold and pressed into shape using a plunger. In casting, the molten glass is poured into a mold and left to cool and solidify into the desired shape. After forming, the glass product may go through additional processes such as annealing, cutting, and polishing to achieve the final product. So, annealing, once the glass has been formed, it is slowly cooled and in a process called annealing. So, finishing, the glass is then cut, polished, and treated as needed to achieve the desired final product. So, see, glass, this can include adding coating or treatment to improve the strength, clarity, or other properties of the glass. So, quality control throughout the glass making process. Quality control measures are in place to ensure that the glass meets the required standard for strength, clarity, and other properties. Overall, the process of making glass is complex and requires skills, technician, and advanced equipment to produce high quality glass products.
I'm Jimel M. De La Cruz. Types of glass. Glass is produced and fabricated for various applications of use. First, float glass. Float glass is a type of glass that is made by floating molten glass on a bed of molten metal. This creates a uniform thickness and flat surface, resulting in high quality with minimal distortion. Flat glass is a highly versatile and widely used material that has a variety of benefits and advantage over other types of glass. Next is low iron glass. Low iron glass, also known as ultra clear glass, is a type of glass that is manufactured with a reduced amount of iron oxide. The absence of iron oxide results in a glass that has significantly higher clarity and transparency than regular glass. Next is annealed glass. Annealed glass is a type of glass that is cooled slowly in controlled environment to relieve internal stress, resulting in a reduction in the overall strength of the glass. And it is the most common type of glass used in windows, doors, and other applications where safety is not a priority. Next is tempered glass. Tempered glass, also known as toughness glass, is a type of safety glass that is 4 to 5 times stronger than annealed glass. Next is heat-strengthened glass. Heat-strengthened glass is a type of safety that is created by heating annealed glass bonded together with an interlayer of polyvinyl butyral or ethylene vinyl acetate under heat and pressure. And the last is laminated glass is a type of safety glass that consists of 2 or more layers of glass bonded with the interlayer of PUB or EVA. Common ingredients to obtain glass. Sand. Sand, also known as silica or silicon dioxide, is one of the main ingredients used in making glass. To make glass, silica sand is mixed with another materials such as limestone, soda ash, and feldspar, which help to lower the melting point of the silica. The mixture is then heated at high temperature in a furnace until it melts into a liquid state. The molten glass is then poured into mold, where it is allowed to cool and solidify into the desired shape. The quality of the sand used in making glass is important, as impurities such as iron oxide can give the glass a greenish tint. To ensure high quality glass, the sand is often washed and purified before use. Additionally, recycled glass, known as cullet, can also be added to the mixture to reduce the amount of virgin sand needed, making the glass making process more suitable. Next ingredient is soda ash, also known as sodium carbonate, is another important ingredient in the manufacturing of glass. It is usually added to the mixture of sand and other ingredients to lower the melting point of the silica and improve the flow of molten glass. Soda ash is obtained from naturally occurring deposit or can be produced synthetically by reacting sodium chloride or salt with limestone and carbon dioxide. In the glassmaking process, it helps to reduce the melting temperature of silica from 1700 to 1200 degrees Celsius, making it easier to work with and reducing energy consumption during the manufacturing process. In addition to its use in glassmaking, soda ash has a variety of other industrial applications, including as a water softener in the manufacture of soap and detergent, and in the pulp and paper industry. Last ingredient is limestone. Limestone is another key ingredient in making glass. It is in sedimentary rock composed mainly of calcium carbonate. In the glass manufacturing process, limestone is added to the mixture to lower the melting temperature and improve the overall workability of the glass. When limestone is heated together with the sand and soda ash, it composes into calcium oxide and carbon dioxide. The calcium oxide then reacts with the sand and soda ash to form a glassy material. The use of limestone also improves the chemical durability and strength of the glass. In addition to its use in the glass industry, limestone has a wide range of applications such as in construction, agriculture, and chemical industries. Main properties of glass. First, transparency. Glass is transparent, which means that it allows light to pass through it, making it useful in applications such as windows, lens, and optical fibers. One of the fundamental characteristics of glass is transparency. It allows to glass capacity to let light through and allow objects to be seen through it, given that it allows a large portion of visible light to flow through it without noticeable distorting or being significantly absorbed. Second is hardness. Glass hardness is yet another crucial characteristic. It speaks to the glass resilience to abrasions or scratches. Glass is tough substance that is challenging to scratch or harm. Glass chemical makeup and how it handled during the manufacturing process affect how hard it is. Glass is a strong substance that can survive wear and tear over time due to its hardness. Glass can still be scratched or damaged by hard or sharp items. Despite the fact that it's a durable material, glass can be given specialized coatings or laminates to boost its durability and hardness, which will help avoid scratch and damage. Next is chemical resistance. Another crucial characteristic of glass is its capacity to withstand chemical attack from a variety of chemicals. Glass has a high degree of inertness, making it resistant to most chemical reactions. Strong chemical bonds between the atoms in the glass structure are to blame for this. For applications like laboratory glassware, chemical storage, containers, and medical equipment. Next is thermal resistance. Another crucial characteristic of glass is its resilience to heat. It describes glass capacity to tolerate extreme temperatures, devoid of breaking, melting, or going through any other kind of physical or chemical change. Next is durability. Glass durability is yet another crucial quality. Glass is a tough substance that can resist a lot of abuse. Because to its resistance to impact, abrasion, and scratching, it is perfect for usage in a wide range of industries, including glass including consumer goods and building construction. Glass is durable because of its chemical resistance and toughness. Next is, and last, electrical insulation. The electrical insulation of glass is the next significant characteristic. Glass is a superb electrical insulator, meaning that electricity does not conduct through it easily. Glass is the perfect material for electrical devices like insulators, capacitors, and transformers. Because of its characteristic, glass has a high electrical resistance which prevents current from passing through it and lower the risk of electrical shock while safeguarding the equipment. Kinds of ceramics. First, stoneware is a type of ceramic material that is fired at a high temperature, typically between 1200 and 1400 degrees Celsius. It is known for its durability, strength, and resistance to chipping and scratching. Next is porcelain. It's a type of ceramic materials that is known for its strength, hardness, and translucence. It is composed of a mixture of clay, feldspar, and quartz. It is often used for tableware, tiles, figurines, and decorative objects. Next is chinaware. It is a type of ceramic dinerware or tableware that is made from a mixture of clay, feldspar, and kaolin. It is typically made from a combination of materials that include kaolin, feldspar, and quartz. Next is bone china. It's a type of porcelain that is composed of bone ash, feldspar, kaolin, and sometimes other materials. It is a type of soap-based porcelain that was first made in England in the late 18th century, and it is known for its thin and white appearance. Last is earthenware. It's a type of ceramic ware that is fired at a relatively low temperature, around 1000 to 1200 degrees Celsius. It is made from clay that is mixed with various minerals such as feldspar, quartz, and talc.
Hi, I am Mark Daniel D. De La Cuesta of AETC 3201. Types of ceramic materials. Ceramics are omnipresent from our kitchen pantries to tool closets. A ceramic is a material that is neither metallic nor organic. It may be crystalline, glassy, or both crystalline and glassy. Ceramics are typically hard and chemically non-reactive and can be formed densified with heat. Number 1. Example. Tiles. Ceramic tile. A tile made from clay that has been permanently hardened by heat, often having a decorative glaze. The sample number 2 is glass. Ceramic glass are polycrystalline materials produced through controlled crystallization of base glass, producing a fine uniform dispersion of crystals throughout the bulk material. And the number 3 example is bricks or brick. A brick is a small rectangular block typically made of fired or sun-dried clay, usually used in a building. Mga ginagamit sa mga chimney or building, ganon. This is the sample number 4, carbide. A ceramic carbide or carbide ceramics are extremely resistant against high temperature, abrasion, or corrosion. They have a high thermal and variable electrical conductivity and are mainly used in mechanical engineering, chemical, and power engineering, microelectronics, as well as space engineering. That is carbide. The example number 5 is silicon. A silicon carbide ceramic are known as SiC SiC, is an advanced ceramic material containing silicon and carbon. It occurs in nature as the extremely rare mineral moissanite synthetic. SiC powder has been mass-produced since 1893 for use as an abrasive. Raw material procurement. To begin the process, raw materials are transported and stored at the manufacturing facility. The raw materials used in the manufacture of ceramic range from relatively impure clay materials mined from natural deposits to ultra-high purity powders prepared by chemical synthesis. Naturally occurring raw materials used to manufacture ceramics include silica, sand, quartz, flints, and silicates, and aluminosilicates. The raw material procurement department is the most important segment of manufacturing company. The major part of the production cost is the cost of the purchase of raw materials from the suppliers. It is an art to create a strategic plan for the purchase of materials for the production. Raw material procurement example. Number 1 is mixing. Mixing or mix. This is you're combining or putting together to form one substance or mass. Number 2, forming. Forming is a process in which the shape of a partly finished product, for example sheet metal, is changed using plastic deformation. During forming, force is applied to a piece of sheet metal to change its shape rather than remove any material. Or like example in a clay, forming a clay. Number 3, green machining. Green machining is considered as an alternative to use of cost-intensive shaping tools. It covers the cheap removal of advanced ceramics with a defined as well as an undefined cutting edge in the green state or the state after debindering and firing. And example number 4 is drying or dry. Dry. Free from moisture or liquid, not wet or moist. And the example number 5 is presinter thermal processing. Thermal processing is a full acceleration. Thermal processing is defined as the combination of temperature and time required to eliminate a desired number of microorganisms from a food or product. Example number 6, glazing. The meaning of glazing is the act of furnishing or fitting with glass. Example, the business or work of a glazer. Paints or sheets of glass set or made to be set in frames as in windows, doors. Example number 7, firing. The action of setting fire for something. Example, the deliberate firing of 600 oil wells. Example number 8, final processing. Final processing means bone fragments and non-combustible items such as metal debris are separated by hand or by magnet. The bone fragments are placed into a cylindrical processor and further pulverized or crushed into small uniform fragments.